Hi, I'm Dirk le Roux. I'm the CEO of SprintHive. We're a fintech company, 10 years old. We're servicing the financial services industry in South Africa, retail credit providers, banks and insurers. We automate the hard tasks to automate, the stuff that's traditionally done manually. And we've recently published a white paper. Technically, yes, we have and we can train an AI to read bank statements, but we cannot do it in a production operational manner. The cost always becomes a problem if accuracy is considered, and then time is always the biggest issue. And losing a customer due to time is never acceptable because that's always a bigger loss than any kind of operational cost. So while the technical answer is yes, it's not operationally ready for mainstream. What is an LLM? An LLM is basically a large language model. Today, when anybody says AI, they mean LLMs. A few years ago, they meant machine learning. So the term AI is sort of the umbrella term for the cutting edge in data science, which currently is large language models. And large language models have evolved to be multimodal and to be able to handle not just language, but images and other media. They're basically a massive aggregation of the human knowledge, of written knowledge. And they're word predictors that we use to ask questions and do all sorts of interesting tasks like writing code, having chatbots, and people ask them for advice and all sorts of interesting things. So you would know them as ChatGPT, Gemini, Grok, any of those models. When people hear AI, they think of AGI, which is artificial general intelligence. LLMs are large language models, and an artificial intelligence or general intelligence is a thinking machine that thinks and reasons like human beings do. LLMs appear to do that, but they don't really do that. What they are the next word predictors. So what it does is you write a whole question, it takes that question and predicts what the next word should be, so it writes its first word. Then it looks at your question and its first word and it predicts what the next word should be. And the models are so complex and so large that output of that feels like reasoning and feels like it's a thinking machine, but it's really just mimicking what humans have done. It's got training data for thousands of millions of human documents, and it knows what humans sound like, and it mimics that. The newer reasoning models are attempting to bring reasoning into it, but it is reflecting on different versions of that same prediction. So it isn't really thinking like you and I would think. LLMs seems to be on a graph where bigger models are smarter models. So the more compute power we give them, the more parameters we put into these models, the better they do. There was a prediction of a ceiling we were supposed to hit a while ago, and that might still exist, we don't know. But so far, models just getting bigger, using more electricity, more neurons, bigger GPUs, just means better and better models. So models getting bigger and being trained on more parameters is definitely the next what will keep happening, but also increasing the multimodality of them. Models are now generating images and video and understanding images and video, and getting more and more input and output from these models is probably the next big thing. Client onboarding is traditionally a multi-step process where, let's say you want to apply for some credit. You start off by giving some information like your ID number. That triggers a credit bureau check and a blacklist check. And then after that step, you can progress where you do a declaration. You say, this is who I am, this is what I earn, this is my affordability calculations, and that all gets verified to qualify you for that account or that loan. And then you've got to prove what you've declared. And traditionally, you provide documentation. You would go into a branch and somebody would see you. You provide your bank statements and pay slips. You know, we've all heard that thing. Can you come into our branch, bring 3 months bank statements, a copy of your ID and proof of address? And then those documents go into a queue where there's a human sitting and just processing those documents, sitting with a bank statement and a calculator and working out your income and your expenses and checking that they're valid. And yeah, so that's the traditional process, big call centers with lots of people sitting doing lots of manual work. So once you automate that, multiple things happen. So firstly, you offload the easy work from those humans so they can focus on the exception cases and catch more fraud and onboard more customers. So by automating a big chunk of it, you can increase the size of the funnel so you can have more applications coming in. The other thing is you can move into digital channels where people can apply online and have a full omni-channel experience where you can start online and go into the branch. So automating that process involves verifying that the person are who they say they are. So verifying the face against a known source like a Department of Home Affairs or an existing customer database, and doing a liveness check, making sure that this is not somebody holding up a photograph or using a deepfake, using AI to fool you. And then for the income verification, the steps are, you've got to firstly read the bank statements and pay slips, get the text off the paper. Then you've got to reconstruct the meaning from that text. What is the salary? What is the account numbers and all those things? And after that, you have to verify that it matches what the customer declared. So there's multiple steps where AI can help, but reading the document, figuring out which transactions are income and what is expenses, all these different things can be automated. How SprintHive approaches the verification of documents and data extraction of documents is what we like to call the Hive Architecture, where we verify the results by extracting using multiple agents to extract the data from the bank statement. So if you think of a bank statement, you need to read the name, the address, and the transactions as a bare minimum. So we have a name detector that looks for the honorific or title, so for Mr., Mrs., and anything behind that, and that it votes that's a name. We have another one that knows what the shape of an address is, and it finds the address, and it looks above the address if there's a name, and it uses that. And there's multiple strategies to detect names. Some banks have a label pair where it says name and then the applicant's name. And so we write all these agents that does all this detection, and then afterwards they all vote on what they think the correct name is. And then we use a consensus algorithm to get the most likely correct answer. Same with the way we extract transactions. We have multiple table detectors that looks for the columns, and we have multiple transaction detectors that decide which rows constitute a transaction, because some banks let transactions split across multiple rows and even multiple pages. Some repeat the date, some don't. So again, we have this combination of table detectors and transaction detectors, and we use a Cartesian product of all of them, which means that at the end, we actually have 60 copies of each bank statement. Once we feed one bank statement in, we get 60 different copies of it out, and then we use those 60 to pick the most likely correct one, looking at the consensus and all sorts of validation data like running balance validation and things like that. So the big emphasis is on correctness. So in a regulated environment where making a reading mistake on the bank statement could be a compliance issue and result in reckless lending or a fine for the financial institution, we need to have a high accuracy rate, but more importantly, we need to know when we're not accurate. So a big focus is placed on validation of the data so that we only automate when we're sure we are correct. So we often get the question is, can't AI just do this whole process for you? And the large foundational models today, if you do a quick test, will probably give you an accurate answer. The problem is in the aggregate, these models do hallucinate, and OpenAI themselves have published a paper that proves mathematically that models will hallucinate. And it's a simple mathematical fact of these models predicting the next token, that they do have to compress the data, and that the next prediction is the most likely correct answer and not always the verified truth of the matter. So the other reason the models do hallucinate is that the way they are trained is with reinforcement learning, which means the models are sycophantic in that they want to please the user. So they want to give you an answer that you expect, and that also leads to hallucinations. We have seen cases where the model feels that statistically there should be a Woolworths transaction in this bank statement based on all the other data it sees, and it will just add a transaction. Or where someone's middle name is Professor with 2 Fs, and it will just correct the spelling mistake and make it 1 F, and things like that. But hallucinations are an inevitability, and the way to detect them is to use multiple AIs, or to have a deterministic system at the end that verifies it. So if you are going to use an LLM or an AI to read bank statements, you'd have to do at least 3 different models. So you'd have to use Grok, Gemini, and OpenAI, and then compare the results. And if they all agree, you automate, and if they don't, you refer to human for review. That's about the only way we've found, and the industry is sort of in consensus with that. The models get high percentages of accuracy in a lab where data is very predictable, and your test set, your analysis set matches your training sets. But in the real world, that will never happen because banks change the formats of the bank statements. So you'll never have a direct comparison between your training and validation sets and your production and reading set. Because when the banks change the layouts of their bank statements, the model will have to start inferring, and the moment it starts inferring, it will start to hallucinate. So that's why it's important to have a verification system and a deterministic system that verifies it at the end. The problem with doing multiple models is the cost becomes so exorbitant that it ends up costing more than the humans to do the automation. And this is already also a known fact in the industry that at the moment where AI can replace humans, it tends to cost more to replace the humans than the humans. And then the last thing then becomes, well, it's speed. You think the AI would be much faster than humans. Average humans captures a bank statement in about 15 minutes, and the average model takes about 10 minutes. So the speed saving is only 30%, where the cost increases, and you're also going to have to go at the slowest model speed. So the more accurate the model gets, the longer it will take to infer. So by the time the model gets as accurate as humans, it'll be take as long as humans and cost more. So using AI, we keep testing all the new models and seeing if there's a way to make them faster. But we have found that using AI would be cost prohibitive and time prohibitive. The reason time is so important, if a human can do it in 15 minutes and an AI in 10, you'd still want the saving. It doesn't really matter once you go over a few seconds, because what you really want is a human uploads their bank statement and the immediate feedback is, sorry, that bank statement is too old. If you wait 10 minutes, the user has left your journey and now you send them an email, sorry, send a new bank statement, you get a massive drop-off rate because people don't come back and re-upload documents. But while they're in the journey and in the process, if you can give instant feedback, the data response is much higher and the abandon rates is much lower. So yeah, the using AI outright is not an option. We've also played with training our own machine learning models to fit as one of those agents in our Hive, and using computer vision separate to OCR and doing a comparison with that. But again, the time, inference time is just always too long. The biggest misconception of the role AI will play in client onboarding that we find in the market is the 100% automation myth. A lot of people we engage first time expect 100% automation. The AI will take over. There will be no more humans in the loop, and all onboardings will take under a second. The reality is that all AI, because of the hallucinations, do require human intervention. There's also actual legal reasons, proprietary reasons, that require human in the loop. So the idea of getting that 100% automation is flawed in multiple aspects. You need the feedback from human to keep training the AI, because I always say machine learning means human teaching. So giving that feedback. And like I said, there's regulatory reasons where people need proprietary requires you to have a human review and a human escalation path. And this, I think the second biggest myth that we see is that AI will replace human jobs. All automation has the potential to replace jobs, but it is rarely that it does that actually. If you think about any business, you can say I can reduce the cost by replacing a bunch of humans with some automation, or I can completely increase the input, the top line of your business by maximizing the capacity of those humans. So for a business user, you can say I can take away 25% of your cost, or I can multiply your business by 4. And it will always be a better business case to have more business, right? To make more profit. So there's always the same team of people that can do X amount of work, can do the system with automation can handle 4X amount of work, and business will always pick that. And that it's easy to see in history when farming, for instance, got automated. Everybody says, oh, there will be no more farmers, there will be no farm workers. We just produced more food. When computers went into life insurance, we could just insure more lives than we could with paper. So whenever automation happens, people always predict the steam engine will take all our jobs, then electricity will take all our jobs, then computers will, the internet will, AI will. But actually humans will be, we will produce more and we will be more creative. I have no doubt that some industries will be affected, obviously, like with all of these revolutions, but yeah, that's it will be affected, but new ones will be created, as always. I think in the future, in the short-term future, AI will play a role to enable faster client onboarding by doing statistical analysis and building better processes and designing better processes and things like that. In the further future, they will become faster. The compute will become faster. NVIDIA will build better GPUs, and inference will become fast enough that they will actually be able to be used to do the work. So the deterministic systems we use today will be replaced by AIs eventually. And that's why, you know, we keep testing these models as they come out, and regularly doing tests and verifying at what price point they can read documents, at what price point they can infer. And already it's playing a role in generating training data and verifying training data. We, after the fact, we have transaction classifiers, and we use these models to reclassify them out of sequence so that the customer doesn't wait. And then we can check if our current classifiers are still good and how they compare with models. We do the same with extractors. So they play a role in the process, but not directly in the client's journey because of the massive time delay. So.